In this video, we are going to do some crazy stuff. I'm going to clone a really big repository of the Linux kernel and gonna see like how it performs, how the Git commands perform on a really huge code base, how is the latency, how much time it takes. I want to explain you essential concepts and the commands of the Git that you need to know if you have a really big repositories, and these are the things that real world tech giants are using for their project. So before we start, if you are new to my channel, I humbly request to subscribe to my channel if you like my content, because seeing that support from you guys, it really cheers me up, it motivates me, and I keep on doing a similar kind of content in the future. And I am very really active on the LinkedIn. So if you have to connect me or just ask me something or just say hello, so then don't be a shy and reach out to me over the LinkedIn from the URL what you see. And the reason I'm making this video because I got inspired by this talk by the Scott Chacon. He's the co-founder of the GitHub, and he delivered this talk in the Brussels, Belgium this year in February. And it was really interesting talk. I watched that video a couple of times, and I learned few things that were very interesting, and that's why I decided to take that theoretical knowledge and apply it to actual case and see how it works. I want to test the things on my own and see the results. So when we talk about the big repositories, what are the really big repositories? Like, what is the definition of big repositories? So I would say Windows 11 is a really big repository. In fact, it is the biggest Git repository that exists on the planet Earth. So in 2017, Microsoft decided to move its all the Windows code base to a Git. They decided to adapt the Git for their version controlling, and in 2017 they started to migrate the code base to a Git, and now all the Windows code is basically hosted on the Git. And let's have a look in terms of the stats. So repository includes about 3.5 million files that weigh in about 300 gigabyte when you check them into a Git. Git, however, wasn't built for the project of this size, so Microsoft developed a Git virtual system to be able to get the benefits of Git. So yeah, they developed their internal tool, their internal project called Git virtual file system, and ultimately that had some really good concept like the scalar that eventually got merged into a Git, and now it's open source. And for now, today itself, Microsoft uses a Git, and it has like so many files, and they are efficiently able to do that. And that's a motivation. I think if you have a project of that scale and you are able to adapt Git to it and manage the things very efficiently, I think that's a really good demonstration and the motivation. So I think credit goes to Microsoft for this awesome work of managing the humongous project on the Git. So let's see some numbers about the Windows repo. So today it has like around 4,000 engineers work on the Git repo. Imagine you have 4,000 of the developer working on this single repo that has 3.5 million files. It has 1,716 average of the daily lab builds that runs on the 440 branches. Wow, these numbers are staggering to me. And it generates like thousands of pull requests and the validation builds every day. I mean, this is a skill that I want to I would love to work on. So when you work in such a project, like, of course, you have such a code base, you are not going to work on all the code base at the same time. It's going to be you're gonna work on the particular piece, particular part of this project, a particular module of this source code. And that's where Git is designed in such a way that you can utilize some awesome concepts, some commands to pull only a specific part of it, clone a specific part of it, work on it, and avoid the latency in the pushing the things, or avoid the unnecessary delay in the Git status, all those things. Another example is of the Chromium. So Chromium, it is available open source on the GitHub, and it has millions of files, which is actually 43.12 gigabytes. I checked the size on my own. I use the GitHub's open API to check the size of it, and it is 43.12 gigabytes of space. Then we have a kernel of Linux. It is also open source, available on the GitHub. So there are 84,338 files, which consumes of 5.15 gigabytes of space. So this is also a thing. So what I'm going to do in this video is I'm going to clone these two repositories in my local machine on my Mac, and I am going to perform some commands. And through that commands, I want to demonstrate that when a developer work on such a really big project, how they work, how collaboration happens. There are some essential commands and strategies that I want to demonstrate, like how you can take a partial clone or how you can optimize the things. There are a bunch of new things added in the Git, which helps you to deal with such a large scale project. So I'm gonna show you all those things in a coming moments. Linux kernel, GitHub repository open here, and the chromium source also over here. So what I did is I just cloned both of them. In my VS Code I have opened both of them, so I have chromium and I have the Linux. So as you can see that I have both of them, and it wasn't fast actually. It took me a lot of time for me, and as you can see that it basically has so many objects, and with a good internet speed also, it took me 30 minutes to clone the entire repository. Just for one repository I'm talking, I think for both it took like 1 hour for me to just clone it. Okay, so the first command that I want to show you is git clone depth, and we can specify how many number of commits we want. So if you are on a particular branch, you can specify like how many recent commits you want to pull from the remote or from the origin. And the syntax is like this: git clone depth. You provide the count of the commits. For example, I'll have something like, let's say, 5 commits, and then I'll provide the path of the my git, and in that way it will clone the repository, but only with the recent 5 commits and not everything. And similarly, instead of commit, if you are interested in just one branch, then you can use this command, which is git clone, then hyphen hyphen branch, then branch name, and hyphen hyphen single branch. So it basically instructs Git to clone only single branch and not all the branch. And with you basically you take off that extra task for the Git to fetch the all the branches and the downloading all the commits. So it's really efficient. If you are working on just one branch and you're not interested in all the branches, then you can make use of this command. So whenever you're working on such a big project, there are multiple people working on it, and you have so many updates done on the remote or on the origin. And if you have to get all the stuff from the remote, for example, a newly created branches, or there are some tags that are newly created or some commits, you basically use this command, which is git fetch. I do a git fetch over here in this repository, it is gonna take a time, because what fetch does behind the scene is it basically make a request to your origin, to your remote, and ask basically, hey, tell me how many files or how many new branches are created there. I have this local version present on my machine, on my client. Is this correct with you? Like, how many commits do you have after this, or how many new branches are created, if there are any new tags created? All that information it is gonna fetch from the remote server. And as you can see that it is basically taking a lot of time. That's not you how you work. If you are I mean, that's definitely not efficient, taking this much of time. So it took like, I guess, more than 20 seconds. Now, to handle this problem, there is this command called git for each reference prefetch. Now this means that as a developer, if I'm working on something else, behind the scene Git will keep on prefetching this stuff without bothering me, and that means that, like, it will schedule some cron job behind the scene. Git fetch, it took like 0.15 second, and if I do it again, let's see how much it takes. So that seems almost constant. It is, the CPU usage is varying actually, but the time seems very less now. Now let's move to the next command. So usually if you have to see a history of commits or the logs, what happened on your branch, then you use this command, which is git log. So you can basically log a graph of all the commits that happen. If you have the merges happen between the branches, it will show you that in your console itself. So time git log graph, if I run this, let's see how much time it takes. And I'll keep video on just to demonstrate you that it is taking a time. Okay, so I think, yeah, it was able to pull the things, the history, and I can see the commit and the details, like who is the author and when was this commit performed. This is from today itself. What was the commit hash and all those things. And it has a bunch of information that it fetched, and that's why it took a time for that. Unfortunately, I guess it didn't print my time, how much took. So this is actually a problem if you have a big repository and if you want to see this log. Then if you want to get over, so if you want to shorten this time, then you can use this technique, which is, so if you want to shorten this time, there is a command and this configuration, which is fetch write commit graph true. So what it does is it basically tells your configuration that whatever commit graph you have, whenever it's going to fetch that, write it somewhere. And with this, actually it shortens the time. If I do a git status and see how much time it takes, so it's taking 1 2 3 4, and it is basically, it went through some time. Usually it doesn't take that time, but because we have so big, and it says that my branch is 13 commits behind, because I guess from the time when I have cloned this locally, there are 13 commits already happen on the GitHub by someone else. So from this thing you can imagine like how big is this project and how many contributors are there and how frequently it keeps on changing. Okay, and it took 4.50 seconds to enumerate untracked files. And though I don't have anything change over here, I don't have a single thing change. But when I run the git status, it basically performs the check. It enumerates through all the files and checks that whether there is anything change. Hence, which is not actually efficient, and hence to get over this problem, Git provides this configuration which is fs monitor true. So what fs monitor means is file system monitor. It basically tells that in the configuration set the file system monitor flag true, and when that flag is true, it launches a daemon behind the scene, and the job of that daemon is to track all the file changes that are happening. And it is not like whenever you do a git status, that time only it will perform the changes file check tracking, but it will be performing that behind the scene always, and it will cache that somewhere. So in that manner, whenever you are going to perform a git status, it will not basically take that time. So I think we have set that true now, and something has changed over here. I guess it has launched the daemon thread behind, and that's why it's performing check. And if I have to do a git status now, I'll do git status, and I need to provide this flag uno, which is basically untracked files. And if I do a time, then this time I can see that it took like a 0.06 second, which is pretty fast. And use -u to show untracked files only. So the gist of it, if you have to check the status frequently, then it is good to set this configuration core fs monitor true, which will basically spin up a file system monitoring daemon behind the scene, and this will speed up your git status time. Partial cloning. So partial cloning is like a putting a filter. Now with the partial cloning, you can basically instruct your git that I don't want certain type of files. So for example, if you are cloning a Linux repository, you can put a filter like filter blob none. That means that all the binary large object or the blob object that are present in the repository, it is going to skip them, and it will basically download all the things except the blob. And similarly, you can do with the tree. If you have the work tree set up in your repository, then you can say like hyphen filter equals to tree equals to 0, and it will not download the tree. And with that, you will have pretty fast download operation, and it will not take a time. So sparse checkout is an optimized version of your depth and the single branch. In this case, instead of branch, you can basically instead get that I'm interested in only specific directories or specific modules. Now after understanding all those things, like question comes to our mind, okay, if I have to set up a big repository, then I have to configure all those things like putting the core fs monitor true, then the commit graph right, like setting up this configuration or setting up the prefetch. I have to do that all those things by my own as a user. There should be some option that those things will come by default if you have a big repository. So that's why Git has launched a new command recently, which is the scalar. Now if you perform the scalar, this is like a tool, and this was developed by a Microsoft. Now it is an implicit part of the Git. So it is a tool for managing large Git repositories, it says. And if you perform a scalar clone, instead of doing a Git clone, if you do a scalar clone and then perform a branch name, then it will have all these options like a prefetching, commit graph, file system monitor, partial cloning, sparse checkout, all those enabled by default. And if you have to tweak it or override it, then you can always go there and you can specify the customization, as you can see in this image here, that